Okay, folks, welcome to the February 2022 event for the Atlanta Kubernetes Meetup. My co-host Joe's not here with us tonight, unfortunately, so I'll be flying solo, but we still got some great content and solid speakers and even something a little different for you tonight. As always, I want to kick off with asking for any announcements for hiring in the community. If your company or you are hiring for roles relevant in the cloud native space, go ahead and post your information in the chat. And I will read those out in just a moment and also post those in the show notes. Be sure to include contact information and any information about the role, why somebody might be interested in joining it or your company. And Saad, also one of our speakers, has an announcement for some roles. I'm gonna go ahead and hand it over to him and let him explain some opportunities.
Yep, absolutely. Hey guys, Saad, Malik, CTO and co-founder here at Spectro Cloud. So we are a Kubernetes management platform, and we are definitely trying to hire the best and the brightest in all areas. We have open roles inside of DevOps, people who are really comfortable working on Kubernetes, both at the infra level as well as on the integrations. We have lots of different hirings for backend engineers, UI engineers, whether you are a junior just starting fresh or you're a very seasoned lead, we're looking for everyone. And the only other role I can think about that we're also looking for, at least on the engineering side, is a developer experience. If you're comfortable working with, if you're comfortable bridging between development, between product and marketing, please come talk to us. We could definitely use you. So, and I'll post in the chat link, spectrocloud.com/jobs, where all these roles are listed.
Awesome. Yeah, and those will be in the show notes as well, folks. So if you're watching this on the recording later on, just check the click the link to go to the show notes. You'll be able to find that link as well. Cool. I don't see any other announcements in the chat. If you've missed the window but you still have something to post, go ahead and post it in the chat, and I'll still include it in the show notes as well later on. So moving on from there, I always want to thank our sponsor, SalesLoft, for providing us our webinar and all our fancy Zoom license for everything we need to bring this to you. We are hoping to get back in person sometime this year, so hopefully they'll also be providing us facilities and beer and pizza and all that fun stuff as well soon. Okay, so moving on to our speakers. During the speakers' presentations, feel free to use the Q&A feature of Zoom. If you look down in the interface for Zoom, there's a little Q&A button. Just click that, put your questions there. The speakers will catch them, and if they don't see them, I'll interject during their talks to also make sure those questions get answered. Make sure to stick around after the presentations today. We usually have our social time. We're going to do something a little different around our second talk. I won't spoil it now, but it'll be something kind of fun. And with that, I'm going to go ahead and introduce Saad. We just heard from him. He's the CTO and co-founder at Spectro Cloud, and he's going to be giving us an overview of Cluster-API. Go ahead, Saad.
Thank you. Let me know if you can see the right screen. And I'm going to present our mode.
I see open positions. There you go. Now I see slides.
Yeah,
looking
awesome,
good.
Awesome. Cool. Yeah, thank you. Like you mentioned, Alex, my name is Saad, Malik, CTO and co-founder for Spectro Cloud, and today we'll be talking about Cluster-API. Just a little bit more about myself. So I'm the guy who likes to build and tinker with new technologies, especially in the areas of Linux, virtualizations, and containers. I was part of an early startup in cloud called Clicker Technologies, where we focus on multi-cloud application management. And it's actually where we first started working with both containers and early versions of Kubernetes and Mesos. So Clicker was acquired by Cisco in 2016. And by this time, the enterprise space and everyone around us was starting to look at containers and really looking to transforming their applications to provide best-in-class experiences using Kubernetes and containers. So essentially in 2019, along with other key executives from Clicker, we left to start Spectro Cloud to really make Kubernetes accessible and approachable for everyone. So for the agenda, I was thinking, now this is where I'll say I was thinking I will do a Cluster-API intro, but it seems like everybody on the call is quite seasoned in advance. So if you guys feel like going too slow or this is too basic for you guys, or if there's things you want to teach me, feel free to interject and let me know. I can move faster. But after the Cluster-API intro, I'll go into more of the deep dive into the Cluster-API architecture. Again, just going to go a little bit into how the providers are built, how the operations are done, And then we'll do a couple of different demos, one with Amazon, both using EKS, and then another one with VM-based one. And then we can also do one for bare metal. So good to go. Alex, anything else you want me to cover?
No, that looks great.
Cool. So before we jump into Cluster API, let's just take a quick look at what the typical journey is for Kubernetes users. It generally starts with the experimentation phase, where users are experimenting with Kubernetes and just trying to figure out what this whole thing is all about. So most clusters in this experimentation phase are generally provisioned using UI of managed Kubernetes providers. And there isn't really much room for automation and scripting things to make things just work repeatedly, because we're all in the process of experimenting and learning. But as we start getting more production workloads into our clusters, what we typically find is that DevOps and IT operation teams start getting involved, where they take ownership of these clusters. And they start looking towards solutions and products and tools like Cluster API to help manage the lifecycle of these clusters. Now, just a little bit in the experimentation phase, especially if you're not using a managed Kubernetes provider, there is a different team that is managing the servers and managing the Kubernetes layers that sit on top of it, right? All the different add-ons. And if they are facilitated by scripts, there's a lot of manual hacking specifically just to work on one environment. And as you start working and looking across multiple environments, it becomes very complex. This is where Cluster API really comes in, is that it provides the ability to orchestrate all the core layers in a unified management. This is where it can unify the provisioning of the actual servers, the machines, the operating systems, the Kubernetes layers, and even some of the day two activities that go in Kubernetes on top of it. All of these are managed regardless of which environment that you're supporting and you want to provide. So what is Cluster API? You can think of it, actually, it is one of the most popular Kubernetes orchestration tools. It is governed by the Cluster Lifecycle SIG, the special interest group by Kubernetes, and has a massive community and adoption across multiple different vendors. In fact, if you take a look today, most modern Kubernetes management platforms, from VMware Tanzu, Google Anthos, and even newer platforms, they all utilize Cluster API for its ability to cohesively manage clusters, across both environments and across different clouds. So what sets Cluster API apart is its declarative approach to managing the lifecycle of the Kubernetes clusters. And the key really here is that because it provisions the end-to-end infrastructure, like the compute, the storage, and the networking, along with all the capabilities of provisioning the Kubernetes on top of it, it makes day two lifecycle management a lot easier, where you get additional capabilities like day two scaling operations, error handling and recovery. All these things are possible because Cluster API is able to provision end-to-end clusters with the infrastructure. Now, the way it provisions the infrastructure is using a really cool plugin architecture called providers, which allows different vendors and operators to add support for their favorite cloud or environment. Whether it's public cloud environments like Amazon, Google, Azure, whether it's private clouds like VMware or OpenStack, or any of the other number of environments that they provide. So there are a number of providers that are out of the box provided by Cluster API that are maintained, but there is a big community that are constantly adding additional providers that allow Cluster API to provision the resources like the compute, storage, networking into these various cloud and environments. Again, I'm not going to go through all the details here. You guys are quite advanced users of Kubernetes. It is a declarative management. It's just like how you manage your namespaces, your deployments, and services in Kubernetes. Cluster API is built on Kubernetes APIs itself, and all the benefits you gain from being able to describe what the desired state is and not how to do it. Regardless, and the cool thing about the Cluster API is that even the actual configuration for specifying, I want to provision an Amazon cluster versus a VMware cluster, because of the Kubernetes API style structure and the actual uniformity, it's very easy to read the code to say, I want to provision a VMware cluster versus Amazon cluster. The only differences might be what are the placement settings, what are the actual properties that are different between them. Cluster API does provision, end-to-end multi-master conformant clusters in various different environments. It does provide the day two lifecycle management. It takes these providers also built in all the best practices of each cloud. So in the case of Amazon Azure provisioning a new cluster, you want to make sure that the actual security groups and the security policies are maintained. So what Cluster-API does with its provider implementation is it has all the firewall ports that need to be only open for the API server. For the worker nodes or even the control plane nodes, it doesn't let you actually directly SSH into those nodes. You have to go through a bastion of nodes. So all of these different best practices when it comes to security, when it comes to resiliency, are already baked into these providers. Now, I already mentioned you provision the Kubernetes management clusters. It is a Kubernetes-style APIs, right? And these providers is what allows it, to provision systems end-to-end. Cluster-API runs inside of a management cluster, right? That is obviously, you have to first bring up the management cluster yourself and operate it. But once you install the CAPI pieces inside of it, then you can essentially have a DevOps or IT operations user create these different custom resources to provision clusters. Whether these clusters are going to your Azure, Google, Amazon, or any of the other providers that we talked about. Okay. So now for Cluster-API, the V1 Alpha 4 release, which happened, I think like 6 months ago, they added support for 2 different types of Kubernetes clusters that it manages. One is VM-based Kubernetes clusters, which was there from the V1 Alpha 1. This is 2.5, almost 3 years ago when they first started, where Cluster-API will provision end-to-end clusters and manage the lifecycle of the machines. So in the case of something like Amazon, it will provision the actual EC2 instances. It will provision the networking constructs like your VPCs and your subnets, and it'll provision all your storage aspects like your EBS volumes. The newer generation of support that comes from managed Kubernetes offerings, in the case for cloud, the most popular 3 are going to be your Amazon EKS, your Google GKE, and your Amazon AKS. So now Cluster-API can also cohesively provision and manage the lifecycle even of managed Kubernetes offerings. We're going to take a quick look at the VM-based Cluster-API. This is the original one that started with V1 Alpha 1. Those CRs, the custom resources that you define for Cluster-API, is going to be a cluster resource. This cluster CRD essentially what defines all the constructs like your pod siders, your service siders. These are all the properties and attributes which are common across all the different types of clouds, all the different types of clusters that can be provisioned. And the nodes themselves are actually mapped by a CRD called a machine. Now, to make this work, to make the ability to provision Kubernetes clusters into Amazon versus Google versus an on-prem cluster like vSphere, there has to be cloud API specific CRDs, both for the cluster level and for the machine level. So any cloud specific properties, in the case for Amazon, which region do you want to deploy into? What is your VPC subnets and settings? Those are all specified in the cloud specific resource like the AWS cluster versus vSphere's cluster. Even machines themselves have very different placement property. For example, in the case for an Amazon machine, it would be deployed into something like a specific AZ. It may have a specific subnet needs to be deployed on. Those properties are also captured in the AWS machine versus another provider like vSphere might have properties like which data store is the actual root that's going to sit on? What is the actual compute cluster and host and resource pool? So you're able to provide best of both worlds where you have a common abstraction that you can apply to any cluster in any environment, but still be able to leverage specific placement properties and attributes for each cloud. Now, you could provision an end-to-end cluster with just clusters machine and what's called a kube-adian config, which generates the bootstrapping user data for each of the machines. But Cluster-API does provide a number of helpers that sit on top that make it easier to manage both the control plane as well as the workers. So in the case for the control plane, there is a CRD called the kube-adian control plane, which essentially helps provision multi-master conformant machines. And this is where it's going to be managing the lifecycle of if I'm launching at 3 node masters and I have now an upgrade from 120 to 121, how is the actual rolling upgrade going to happen? and maintain the state of the master. So that's done by this kubeADM control plane. And the workers themselves, if you had 10, 100, or even 1,000 different workers you want to add into the pool, you're not going to manually one by one create a machine CRD. It's just too much effort. So what Cluster API has done is just like how there's pods, replica sets, and deployments, they also have a concept of a deployment operator called machine deployments. And essentially what machine deployment does is it creates machine sets, and machine sets then manage one or more machines lifecycle. Alex, just a quick check. Am I going a little too slow, or do you find this is helpful? Do you want to go a little bit faster?
I think the pace is perfect. I think you're dead on.
Okay. So just taking a look at an example of cluster on Amazon with the VM-based. How does that look like? Right. So obviously, there's going to be some constructs or some resources that the user specifies, and some resources that are generated either based on the CRs or based on Cluster API. Like I mentioned, for every cluster that you provision, there's always going to be a cluster CR that defines the common attributes. Any specific attributes for a cloud, in the case of Amazon cluster, the region, the VPCs, constructs are going to be specified in the cloud-specific option. The kubeADM control plane is the one that manages the actual control plane nodes, and this ties in with an AWS machine template, which specifies what is the actual instance type selections, what is the actual AMIs to use in constructs like that. And on the other side, for the worker nodes, there is this machine deployment. Again, the same AWS machine template can be used that specifies things like, what is the actual instance type, what is the AMI to use, and the bootstrapping of how the actual worker nodes join into a cluster is governed by the kubeADM config template. The purple objects you see below are the ones that are generated. So machine deployment creates a machine set that creates the machines, which ultimately are the nodes which join into the cluster, right? And obviously this kubeADM config that you see here is generated using the kubeADM config template. When a cluster on Amazon is provisioned end-to-end, like I was mentioning, in a VPC, so Cluster API for a public cloud like Amazon provides two different models. One is called dynamic provisioning, where it will dynamically provision all of the underlying infrastructure. In the case for networking, this would be creating the actual VPC, it would be creating the actual subnets, the NAT gateways, the security groups, everything is provisioned for the individual cluster. Now, some customers do have requirements where they want to be more in control of how the actual VPCs are created. They want to have VPC peering. They have very specific security group policies and rules that they want to adhere to. And so what they can do, the other mode of provisioning a cluster using Cluster API on Amazon is you can specify all the resources like, this is my VPC IDs, these are my subnet IDs, these are my security groups. You, instead of provisioning the underlying infrastructure for the networking and storage, or just for the networking, go ahead and actually just provision the VMs themselves onto existing infrastructure. So what I was thinking next is maybe we can do a quick little demo of what it looks like to have Cluster API provision an end-to-end Amazon cluster using VM-based technologies. And then the next demo we'll go into is on the EKS side. I think there's one question. Okay, let me stop sharing. Give me 1 second. Let me reshare my screen.
I don't see any open questions in the Q&A feature right now.
Okay, awesome. I'm gonna just go into and reshare my screen. So I think the best place to start for Cluster API is at the Cluster API SIGs, the actual Cluster API book that exists. I think it's quite comprehensive in terms of talking about what is a project for, what are some of the high-level concepts that I kind of described regarding the machines, the different deployment sets, and the different infrastructure portions. And if you go into, if you go into the quick start guide, there's a very simple instructions for how you can, on your own, inside your own management cluster, maybe even a simple time cluster that runs on your laptop, be able to provision a simple Kubernetes management cluster. And then inside of it, go ahead and install cluster cuddle, which will provision the Cluster API controllers and operators. So I'm gonna jump into my terminal. And Alex, let me know if this is big enough for you guys. Does
it
look
looks
good?
good for me. Is it, if anybody's struggling to see that, just let us know in the chat, and we'll kick it up. It looks good on my end.
Okay. So the very first thing is once you have the K8 cluster up and running, and the K8 cluster actually is a simple command like K8 create cluster. That's all it's needed. What it does is on your local desktop or your local workstation, it creates a simple little container called K8s node, which is a single node Kubernetes cluster running as a container. They have some fancy options if you want to have multiple different replicas and you would have different versions, but it's not really needed for cluster API. Now, the command to actually bootstrap the cluster, to bootstrap cluster API is a command called cluster-ctl init, and you specify what is the actual providers that you want to add into cluster API. So in this case, we're saying we're adding a middle as a service provider, and I'll get to that in a little bit later in the demo. And then we're also adding an AWS provider. So now I have support with this command for both provisioning Amazon clusters as well as bare metal clusters. This is I'm not going to run this command right now because it takes a few minutes to go through end to end, but this is the output of when the command runs through, what happens. Now from here, what we can do is you can generate what's called a cluster specification, right? What does the specification look like for an Amazon cluster? The command you can run is something like cluster-ctl generate, and you specify the name of the actual cluster you want. In this case, I specify AWS VM1. What version of Kubernetes do you want? You can specify properties like, I want the control plane machine count, how many master nodes essentially, and the worker machine count. And the most important thing, of course, specifying is which infrastructure. If you install a cluster API in your management cluster with only a single infrastructure, this obviously is not needed. But because I've added both Amazon and MAAS, it's asking for, hey, which one should I be using? So if I run through the actual command here, right, it takes a few seconds. Okay, so in this case, I had to reboot my computer. Unfortunately, I lost all of my environment variables. But if I run through the actual command, it's going to generate an actual specification that looks very similar to this one right here. No, not this one. Here. Now, let's take a little bit deeper look into what does a specification do. So like I mentioned, at the top level, at the very top, there's always going to be a cluster custom resource. And these specifies attributes that are common for any Kubernetes cluster, whether it's on Amazon, Google, Azure, or even on bare metal. Constructs like your pod siders, it now specifies two different types of other links or references. One is going to be for defining for my control plane, I wanted to use this AWS VM2 control plane object that obviously will be created below that. And then number two, for any cluster level, cluster-wide settings that are Amazon specific, what are those properties? If I look at this infrastructure rep for my Amazon, I specify a region and an SSH key name. If later in the demo, when I show something for MAAS or for another cluster technology, this would be very different, right, as you can imagine. Now, if you take a look at this kubeadm control plane configuration for this cluster, right, I'm defining some very high level properties in terms of when the cluster is provisioned, right, what does the initialization look like? If there's any overrides I have to do in terms of my feature gates or enable additional admission plugins, all of those things can be specified directly in this kubeadm config here. And the join configuration essentially is for my kubelets, right, that are of the actual worker nodes joining into my cluster, what is their configuration going to look like? Here we also specify that I'm launching a kubeadm control plane. My control plane nodes are 3 replicas running version 1.19.1. And by the way, my machine template for when you are provisioning these machines is going to be instance type T3 large, right? Attach this instance IAM profile in Amazon, with this SSH key name. And below this, right, below the actual control plane nodes, we are also going to be showing the various machine deployments. So the machine deployments are the worker nodes that are joining. Again, you'll see the infrastructure ref is going to be very similar to the control plane one. I think actually I use the exact same thing, or the same instance type, the same SSH key name. But you could, of course, and most customers do launch maybe T3 large or T3X large for their control plane nodes, but for their worker nodes, they launch much larger ones, M5, X2, X large. So you can have different instance types for your worker nodes versus your actual master nodes. One more comment I want to make is many customers do also have very heterogeneous type of clusters where you might have some worker nodes or some worker pools that are GPU based, others that are based on large storages, others based on more CPU. You essentially would just create multiple machine deployment blocks. And because they all target the same cluster, Cluster API knows that these are the actual workers that need provision of these instance types. Let me join into the control plane that was defined by here. Any questions so far, Alex? Everything so far so good?
No, none have come in yet. I'll let you know if there's any pending, but we're good to go.
That line number is melting my brain. I don't know why, but I always like the relative line numbers because I'm always going up or down a few lines, right? So if I want to go up 6 lines, right, I just say 6K up. That's why I know most people prefer those long numbers, but I have to type in, go to line number 98, go, which is a lot harder than saying jump 6 lines down. So
makes sense.
So, okay, so what we're going to do next is we're actually going to go ahead and I'm just going to show you, I have an existing cluster that I provisioned on Amazon. So that command is going to be something like cluster kubectl cluster get clusters. If I run this command here, it should show me all the clusters that are provisioned by this management cluster here. So here I have an AWS VM2 cluster that I provisioned a few hours ago. Cluster API provides a really cool helper command called cluster-ctl that lets you get the introspect the cluster for different states, whether it's the state of the machines, the control planes, or even get the kubeconfig file. And that command is something like kubectl describe AWS VM2. Here I'm just telling cluster API with cluster-ctl command, give me the state of the cluster called AWS VM2 and show me all the conditions that are happening. Once I run this, right, it shows me essentially that, hey, I have a number of different clusters or a number of different machines running as my control plane nodes and a number of different machines running as my worker nodes. These are all, of course, running on Amazon. If I was to jump out and go into the Amazon console.
Saad, real quick, while you're jumping, we've got a question in chat. Shahar asks, he says he's wondering if Cluster API handles the non-queue resources similar to the way that a regular operator would. And I think what he's saying is it reconciling the status of these and doing health checks and kind of replacing unhealthy nodes and things like that, like you'd expect an operator to do typically?
A great question. And I think that's one of the big value props of Cluster API compared to Terraform. So Terraform, obviously, we are all very familiar. It does a fantastic job bringing up the infrastructure. But Terraform, even though it's desired state based, it is a fire and forget where you say Terraform apply, it goes and it says, hey, do I have my 3 machines launched on EC2? If not, let me go and start provisioning them. Once that operation is done with Terraform, until the next time you run Terraform plan or Terraform apply, you have no idea whether those machines are up and running, are they healthy, or are they not. This is where the Cluster API reconcile loop really helps. By default, every 2 minutes, it is checking for the state of each and every machine, whether it's the control plane nodes or the worker ones, and it's making sure, are the machines still running? Are they healthy? Are they good? It's not even checking the state that the VM on Amazon is in a running state. It goes even a layer below, a level below that, and it checks for all the conditions in Kubernetes. These would be things like, is the ready status good? Is my network status good? Are my conditions for my CPU, my disk usage, are all of them healthy? If any one of them becomes unhealthy, there is another small controller that runs as part of Cluster API called a machine health controller. And what you can configure for the machine health controller is that if my nodes are unhealthy, meaning they're not in a ready state because of disk usage or CPU or something is wrong with the node, then automatically go ahead and replace it. And so what that operation looks like is it'll launch a brand new node on the actual provider because the machine deployment specifies this is how you can provision any number of nodes. It'll provision a brand new node. As soon as a new node joins into the actual cluster, it'll deprovision the unhealthy node. By default, it does it every 2 minutes. That, of course, is configurable. And actually, if I remember correctly, for every worker node that already is joined into the cluster, it also has it's checking that state of that machine directly by talking to the API server. So even if you power off the machine, in some cases, it can detect it within a few seconds that the node is unhealthy or is now powered off. And so it can either, in some cases, start the machine again, like in the case of vSphere, if you power off the machine, literally within a few seconds, Cluster API will power the machine back up. But if it's not able to power it on because there's not enough resources or some other issue, they'll go ahead and do this replacement where they'll launch a brand new node, join the cluster, delete the unhealthy node. Hopefully that helped. Cool. So now in this case, we are looking at these AWS VM2 machines that are fully up and running. The thing I was going to show is that you can see the control plane nodes, you can see the actual worker nodes, all MD ones here. In this case, it actually did provision the end-to-end underlying resources. So if I look under my VPC section here, right, this VPC that was created here, this was created 3-4 hours ago by Cluster API. So it does the end-to-end provisioning, everything from your VPCs all the way down to your subnets. All the subnets for, it has two different types of subnets. It has public subnets where it'll add all of your actual Bastion node into, and also your NAT gateway is attached to that. And then it'll have private nodes for your control plane and for your worker ones. So those are fully managed end-to-end by Cluster API. What we're going to do next actually is we're going to be doing a day 2 operation. So one of the operations we can do is like, hey, let's go ahead and actually scale my machines from 3 nodes to maybe 5 nodes. So if I look back up into my machine deployment object here for my AWS VM2 cluster, I'm going to say scale this up to 4 number of nodes. And if I go ahead and kubectl apply that into my Kubernetes API, my Cluster API management cluster, right? Obviously, many of those resources were not modified, but the one that was modified was the machine deployment. If I was to do a describe now on the AWS VM2 and look at all the conditions, right? You should see very shortly that there's going to be 2 new machines, AWS VM MD2, that are now being provisioned. If I go back into my Amazon console, if I was to notice, if I go into my EC2, and if I look at my instances, I should start seeing new nodes being provisioned, right? It's as simple as being able to specify, hey, go ahead and specify the new number of replica counts, and the new nodes will be provisioned by Cluster API, and they'll join back into the cluster. There are other similar operations that you could do here would be things like, I want to add additional types of nodes. I want to have not only T3 largest, but I want to have my GPU pools, my G5 clusters instance types. Again, that would just be specifying a new machine deployment, specifying the instance type in the section over here. And voila, within a few minutes, Cluster API is going to be able to provision those as well. And the last operation, common operation that people do at the infrastructure level for Kubernetes is doing an upgrade. If I want to upgrade from one version of Kubernetes to another, in this case, I would just update this version field here. And because Cluster API tries to retain the state of the cluster to be as healthy as possible, it will do a rolling upgrade where a new version, let's say I'm provisioning now v.1.20.1, where it'll first launch another node with version 1.20.1 and have it try joining the actual cluster. If etcd joins successfully, then there's a process of eviction of the older control plane node, and it gets marked as unhealthy and eventually gets deleted. But if your actual new control plane node doesn't join successfully, there isn't really any big impact to the system because all your Kubernetes applications that are running in those clusters are not impacted. They're still running. It's only if the new node joins successfully does this termination of older nodes happen.
So we have a couple questions that have come in. Kieran asks, with the availability of auto-scaling features like the cluster autoscaler, why would we want to manage our machine replicas using the machine set?
Great question. And to be honest, majority of customers, they always use cluster autoscaler by default. It's the way to do it, the way I recommend it. You obviously configure your HPAs, your VPAs, and then you use your cluster autoscaler. This is obviously just as an example that you could, maybe you do have a certain application or certain use case where you need to have X amount of capacity always reserved. Obviously in cluster autoscaler, you could specify min number of nodes, but the simpler way of doing that is just specifying a machine deployment, minimum number of replicas here. What's cool with cluster autoscaler is obviously that they do work with different providers. They do also have a very cohesive integration with Cluster API that regardless of which provider you're using from Cluster API, whether it's Amazon, Google, Azure, or even on-prem, they will manage the machine deployment replica count. So it'll work across any environment that Cluster API provides.
Very cool. Moshe asked, and I think you actually just touched on this, but he wanted to clarify, do the cloud provider plugins for Cluster API automatically use cloud provider specific features like auto scale groups and things like that for instantiating the machine deployments? And it sounds like you kind of just touched on that.
It is absolutely right. So, I mean, that's the benefit of having this provider implementations is that you could leverage the best technologies and the best capabilities that each cloud provides. I'll give an example, right? So on Amazon, if you're doing the VM-based provisioning of the Amazon Kubernetes clusters, it'll provision an ELB that's going to be load balancing across all the control plane nodes, right? Obviously, and it'll create EBS volumes that will attach into each of the different nodes that it provisions. On something like an on-prem cluster, maybe using vSphere, right? If you're provisioning a cluster on vCenter, there is no concept of an ELB, so you can't use it. So instead, what the vSphere provider does is that it uses a technology called kubevip, which will essentially do a leader election between all the three control plane nodes to figure out who the actual IP should belong to. That logic of using ELB versus kubevip versus something else is what's all implemented in the provider side. So that's what they do.
Very cool.
Any other questions, Alex?
Yeah, we got a couple more coming in. We have one from Shahar. I'm going to read this one word for word because I love the phrasing. Sometimes a node is sad for strange reasons. I feel that way too sometimes. Having a broad way of restarting nodes might prevent folks from debugging the apps as well as the nodes on a cordoned or drained node. Have you had issues debugging K8s failure modes with self-healing clusters? It feels like we would want a lot of observability instrumentation before feeling okay turning the cluster off and back on.
Yeah.
So I think
please.
No, go ahead.
Please.
I was going to say, just to summarize, it sounds like he's saying maybe having this self-healing might make it more difficult to observe your failure modes.
It is. And to be honest, I mean, it's obviously in dev and testing, we never recommend that you have that machine health check. I mean, even if you do, it's okay, but you have a long threshold. You do have to add your own monitoring into your Kubernetes cluster separately, right? Whether you're adding things that are looking into the API server, the audits, or the events that are being generated and being sent off to your Slack or your Microsoft Teams or whatever communication channel you use to get notified of alerts. During dev and staging, absolutely, right? I mean, you want to debug, see what happened. But sometimes in production, there are critical business applications that are running. And it depends on per use case, but some you cannot have any downtime, or you want to minimize the downtime as much as possible. And that's where you potentially would want to at least launch a new node to join the cluster. I believe there is a setting in the machine health check where it says, hey, go ahead and launch a new node, let it join the cluster so that I don't have any reduced availability of the cluster, but leave the other node as evicted so I can do troubleshooting on it, right? Obviously, you could have that setting enabled. Okay, just anything else?
We have one other question, but I've asked for clarification on it, so we'll hold off on that one. You can keep rocking.
Okay, I'm gonna share my desktop too again. And so I think we kind of already covered on the VM-based Kubernetes, right, how cluster API resources look. There are different resources when it comes to a managed Kubernetes offering, because in this managed Kubernetes offering, cluster API is no longer managing the state of individual machines. All it's doing is configuring the managed Kubernetes provider offering in terms of this is the configuration and desired state I want you to maintain. Now, there is still going to be a cluster resource that sits on top that obviously all the common properties that are applicable. But for the control plane node, you don't specify a kube-ADM control plane. Instead, you specify what's called a managed control plane. And here, just like in the case for the VM-based one, there is a general managed control plane, and then there is a specific cloud like Amazon managed control plane that you have to specify. And the worker nodes, you're no longer creating the lifecycle of individual machines, whether it's through a machine set or machine deployment, you're just specifying to EKS or to whichever managed Kubernetes provider that you're using, this is my min size, this is my max size, here's my auto-scaling group rules. That constructs are specified in a machine pool object. And just real quickly on Amazon with EKS, you still have the cluster object, you have the AWS managed control planes, the machine pools, which are tied into an AWS managed machine pool. And then of course, you optionally for Amazon and EKS can attach Fargate profiles. I'm sure most of you guys know Fargate. Essentially, it's for ephemeral workloads that are coming and going very quickly, a lot in any Kubernetes cluster. You may not always want to have a worker node there to handle the actual workload. What Fargate provides on Amazon is an ability for worker pods, as they're being provisioned, to have their own dedicated node. And so the use case of this is if you're launching a pod once a day, instead of having an actual worker node always there remaining and only to be there for a couple of minutes when the pod is running, you can use an AWS Fargate to essentially say, when the pod is scheduled, go ahead and launch an ephemeral node that its lifecycle is tied to the lifecycle of the pod. As soon as the pod dies or it's killed or it's deleted or whatever happens to it, go ahead and kill that node. And so this whole thing is managed completely via Amazon and through Fargate. And so just real quickly on the demo side, I'm not going to go through the entire demo. I think you guys kind of understand the whole workflow. I'm just going to show an existing EKS cluster YAML, what it looks like. Again, the cluster resource looks very similar, but instead of a kubeadm control plane CRD, you have an AWS managed control plane. And here, just like in the VM-based Kubernetes, you have two modes of provisioning. You can do dynamic provisioning, where you don't specify any subnets or any VPCs. But in this case, I did specify the subnets of VPCs, meaning provision this Kubernetes cluster into an existing resource, into an existing platform, into existing infrastructure. Here I specified my region, my version, my SSH key nodes. Those are all very, very similar, as you saw in the VM case. But notice that for the AWS managed control plane, there really isn't any replica count, because for a managed Kubernetes offering, you don't manage the control plane VMs. That's something completely done internally by the managed providers.
I'm sorry, is there supposed to be a terminal on the screen?
Oh, are you sorry? My bad, guys. Is that better, I hope?
Yep.
Okay.
Yes. Yeah. Sorry, I should have pointed that out. I thought you were building up to that. Thanks,
no, that was, yeah, sorry about that, yeah. So this one here is the cluster object itself. Like I mentioned, the control plane ref itself has the AWS managed control plane. The infrastructure ref is the one that's specifying the AWS managed control plane. Notice there is no replica count that you're specifying here. But in this case, because the whole management of the management control plane is done by Amazon. And then for the worker nodes, you have the machine pool construct, where you specify just the number of replicas and the configuration, or the number of replicas you want EKS to provision. And then for Amazon, there is an Amazon managed machine pool where you can specify constructs like what are the AZs, what are the subnets, and the auto scaling groups like minimum one number of nodes, maximum 5 number of nodes. And so what we can do is, please.
Oh, sorry. We got a question, another one from Moshe. He asks, if you're going with AWS clusters for Cluster API, is it always going to be EKS, or can a provider also provide a vanilla Kubernetes cluster on AWS via Cluster API?
Great question, right? So if I take a look at this first example here, the one that I showed about 5 minutes ago, this one here, this 9 AWS VM2, this is where Cluster API will provision vanilla CNCF Kubernetes clusters by provisioning the VMs, and inside of it, it'll run kubeadm init to initialize the control plane nodes, and for all the worker nodes, it'll run kubeadm join to join those worker nodes into the cluster itself. So this is where the vanilla Kubernetes cluster comes in if you want this option. If you prefer doing the EKS option, then the CRDs are a little bit different. It's the ones like I was showing here. It's this AWS managed control plane and AWS managed control plane are the ones you specify if you want EKS as the actual Amazon. So for public clouds, for Amazon, Google, Azure, you always have the choice. do you want to use a managed Kubernetes provider offerings using a managed control plane, or if you prefer vanilla Kubernetes, use the other construct. And so what we'll do next is actually we'll go in and provision a new cluster. So here I have an EKS4. Actually, let me take a look. It's already provisioned. If so, you want to do it. So notice that I have an EKS3 provision, but no EKS4. And so what we'll do is we're going to go ahead and actually provision a brand new EKS cluster. Cluster kubectl apply that config. It creates the cluster, the AWS managed machine control plane, and the machine pool itself. If I log into my Amazon console, and let me refresh the screen here. And if I go into Elastic Kubernetes Service, what we should see is a new EKS4 control plane being created. Once this actual control plane and this EKS cluster has been provisioned, inside of it, we will also see a new machine pool get added as well. Obviously, right now, it's going to take about 5 minutes for the EKS control plane to be created. I can quickly jump back to my terminal and show you an existing cluster. So like I showed you before, if I run kubectl clusters, I have an EKS3 cluster, and I can describe with a cluster ctl command to look at its status. Cluster API does not know about the individual machines that are running in this cluster because that is managed completely by Amazon. But what it does specify is that are all of my security groups configured, or is the control plane ready? Is everything good to go? I can download the kubeconfig for this one as well. So if I type in a command like kubectl get kubeconfig, and I can specify my actual cluster name. In this case, it's EKS-3, and this is going to be EKS-3. And if I cat this file, and don't worry, guys, I'll delete the cluster after this demo is over. Right? I'll download the actual kubeconfig for it. And if I set my AWS profile to Picard and do a kubectl get pod command, right? And actually, I didn't set my kubeconfig, but if I set my kubeconfig into demo, and here I go to this is going to be EKS3. I'll set my AWS profile to my system. And if I run this command, it takes about 5 to 7 seconds. But now this call get pods, kubectl get pod, of course, is in that EKS-3 cluster. Similarly, like I did in a previous demo, you can do scaling operations, you can change your auto scaling groups, you can upgrade the version of your control plane to a higher version. That works identical, regardless if it's a VM-based Kubernetes or using managed-based Kubernetes.
Nice. Scott asked, I'm not entirely sure he's not trolling me, but he asks, is there a way to mix nodes from 2 or more cloud providers?
You know, it's funny, Joe Searcy asks me this question every 2 weeks. As we actually looked into supporting that. Can we have maybe a control plane running on one cloud potentially, but for different machine pools, the actual node groups have from different environments? There wasn't, unfortunately, because of the way the cluster API CRD mappings work, when you create an actual node pool that is of type AWS machine pool, it does internally a cast. It makes sure that the actual cluster CRD is also type Amazon. So now the problem is that if you were to introduce maybe, let's say, Azure worker machine pool, internally the provider would try to find a Azure cluster resource, which would not exist. So ourselves actually were thinking, can we maybe provide a higher level controller that is able to have maybe a dynamic, have both of them somehow added inside of it, where it can manage both the Azure as well as the Amazon type of workers. It doesn't exist today, but something that we are interested. If you have ideas on how to do it, please do contact us. We'd love to kind of see it in action.
We have another question pending from Shahar, and I'm just going to read this one verbatim rather than trying to summarize. Declarative tools often don't play well with other tools trying to manage the same resources. I'm wondering what tools are kosher to use with Cluster API. Would you be able to use Node Problem Detector to export node conditions, events, or custom monitor checks before destroying a cluster? Or are there ways to inject a step like a script as a pre-hook to delete a cluster?
Yeah, that's a good question. I think that's a good point that if you're doing observability and visibility into the clusters, making sure everything is healthy, you're reporting on alerts and all those things, those I don't think Cluster API will have any issues with. If you do try to have a read-write operation where you're actually trying to configure, delete a node, shut down the cluster out of band for Cluster API will say, hey, my desired state is I need to have 3 masters, 3 workers, but I only see 2 workers. I have to bring it back up and running. So unless those tools work nicely with Cluster API and they modify the Cluster API's desired state, you're going to get into some level of contention. This is where tools now like Cluster Autoscaler that I mentioned, they actually work on top of Cluster API now where they configure Cluster API desired state to make it happen. Okay, guys, so the last portion of the demo that I was going to quickly get into was just on the bare metal use cases. We've been seeing in the field that there's a exodus, not an exodus in a large scale, but some use cases that are working better on-prem, specifically our bare metal clusters. And some of the reasons that are what we see our customers and users in general moving towards bare metal, of course, is access to hardware accelerated devices like GPUs or FPGAs or other devices, a little bit faster performance, especially if you're running your own vSphere on-prem versus bare metal, because you don't have that extra overhead of going through a hypervisor layer. And for some customers, if they're doing it correctly, the cost of running bare metal at large scales, when you have thousands of machines doing high performance computing or edge computing, is cheaper than having a hypervisor site. Now, and I think the main thing for me is if you think about what Kubernetes provides, it provides an abstraction layer over your compute, your storage network. If you're running a hypervisor, especially on-prem, it provides the exact same abstraction. So now you kind of have 2 abstractions which are kind of providing the same capabilities, right? Do you really need an extra layer of fat in the middle of the hypervisor layer if there was a simple way of being able to provision and manage Kubernetes clusters? So today, how bare metal clusters for Kubernetes are provisioned is you start with 3 bare metal systems, right? On top of the systems, you would have an aspect of installing your operating system. And then on top of what you have the operating system, you would initialize your Kubernetes. Now, this generally in today's world with bare metal is 2 different disconnected experiences. There's 2 different life cycles. One is for dealing with the physical servers, the operating system, and then the other life cycle deals with the Kubernetes lifecycle management. If it's done by different teams, different operators, there could be incompatibilities between how the upgrades happen between the operating system and the actual Kubernetes. And these inconsistencies over time could, of course, lead to cluster availability issues, and as well as it would impact your applications too. Now, and I already mentioned that this could be impact your cluster availability and your apps. Now, if there was there a mechanism to be able to manage your Kubernetes that is running on bare metal as same experience as being able to manage it for the Amazon experience? Now, what would that look like, right, if it was a possibility? So you'd have a management Kubernetes cluster, most likely running Cluster API. There would need to be a bare metal management interface that can interface with the actual bare metal systems and to communicate with them. There are a number of different options in the field today. I think most of us are probably familiar with like Metal 3 or Metal Cube. There's Sidero. There is also Canonical MAAS, which provides a bare metal management interface. It's one of the more popular vendors, popular options because of their maturity. They've been an open source platform for around 12 years, and they essentially work via APIs to many, many different types of hardware vendors. Whether you're talking Cisco or Dell or Supermicro, they essentially support all the different hardware vendors out there. Now, the benefit, of course, for somebody who's building a layer on top is that it becomes just an API. And then if you were to build a Cluster API MAAS provider, which we have now, you can interface with MAAS to provision end-to-end bare metal machines. And because now you actually have bare metal MAAS provider, through the kubeadm config, it can even initialize the Kubernetes that's on top of it. You have the constructs for a MAAS cluster using Canonical MAAS are identical to the VM-based ones. The only difference, of course, are that the MAAS cluster has different properties, MAAS machine deployments, and the MAAS machine template have different properties. But otherwise, operationally, it works identical to any other Kubernetes cluster that you have. So before the demo, any questions, Alex?
Oh, sorry. Nope, no new ones now. Looking good.
Awesome. So what I'm going to do is I'm going to go ahead and show you guys, before I go into the cluster API demo, I'm going to first show you guys what MAAS looks like. And if I log into my system here, so this is a MAAS running in my colo, in my data center. I have around 47 machines that are registered with this bare metal management interface. What MAAS does is it can segregate machines based on status. Like these are machines that have been registered with MAAS but are currently powered off. And then I have machines that are currently in deployed state. And then there's a bunch of small ephemeral states that are kind of transitioning states. You know, as I go through and I deploy a new machine, for example, if I go into a machine itself, I can click on an action like, hey, go ahead and deploy a operating system on top of this. I can select something like an Ubuntu operating system. I can specify which version of the Ubuntu do I want, and I can specify deploy. And then what it's doing now is it's going to be this machine is being communicated via MAAS, via IPMI, right? Where it says, hey, power on the system. And the very first thing as the system gets booted up is it'll go into PXE booting mode, where it'll wait for an IP address and an FTP location for the actual image itself. So what MAAS will do is it'll give an IP address to this machine, and it'll also give an ephemeral operating system to load. And as part of that ephemeral operating system that it loads, they'll have commands that it can talk back to MAAS and say, hey, what is the actual target operating system that I need to flash onto the disk themselves? MAAS, as part of the enlistment process, does a lot of discovery. It can discover things like the number of cores you have, the memory you have, all the networking configuration. There's a bunch of things that it can discover. And it makes it really easy to manage at scale 10 or hundreds of different machines that you may have in your data center. Now, a couple other constructs before I jump into the cluster API demo is they also have a concept of availability zones. So I can say, hey, I might have 3 different racks of bare metal servers, and I can, of course, classify them across different zones. So in this case, I have AZ1, AZ2, and AZ3. They also have a concept of resource pools where you can specify different type of bare metal systems. Okay, so for instance, my bare metal GPU machines can be classified as bare metal GPU versus my general purpose compute hardware could be medium generic, et cetera, et cetera. There is image management. So where you could say, hey, I want to go ahead and have the images that are being managed by MAAS itself. By default, it can automatically synchronize the latest versions of all the canonicals, version 20, version 18, version 16. But they do also have the ability where you can upload custom images. So what I've done essentially is custom built images for Ubuntu with pre-built in the kubelet, the kubeadm, and the kubectl commands into each of the different VMs here. You can, of course, upload your own security hardened versions of your operating systems, whether it's Ubuntu or CentOS or Windows CentOS, it doesn't matter. MAAS supports them all. And the last thing I'll just cover real quickly is because it acts like a mini bare metal cloud, it does also manage the lifecycle of the networking constructs. So you can specify, here's my actual subnet that I want MAAS to manage for all the machines. And then it'll go ahead, as machines are booting up and powering on, it'll give IP addresses assigned from this pool to the machines. So with that, let's go back into the terminal and I'll take a look at one of my MAAS clusters. So here is my MAAS-2 cluster. Like the other clouds and like the other environments, there is going to be a cluster CRD. And the only other difference here is there is a MAAS cluster here. Now, MAAS cluster doesn't really have a lot of properties other than specifying when machines are powered on, which DNS domain are they going to fall under. So in this case, I'm hard coding to say, whenever machines are powered on, they're going to fall under some machine ID .maas.sc. And then for my actual worker nodes, I have a machine deployment. In this case, I'm specifying only a single machine, a single replica, but the other properties are identical, right? A Kubernetes config template that specifies what is the configuration for when the worker nodes are started for them to join into the cluster. And for my infra template, my mass machine template, I'm just specifying what type of machine do I want to allocate from mass. So if you take a look at this one, mass to worker, here, I can specify mass-specific properties like I want machines that have at least 2 CPUs that have 4 gigs of RAM that are on failure domain AZ2, right, with this specific image to use. Now, I'm going to go ahead and actually provision a identical cluster to that. The only difference for this MAAS1 is the name is MAAS1, but all the other properties from the CPUs, memory, replica counts are identical. If I go ahead and I actually apply this into my cluster, into my cluster API management cluster, obviously all the resources are being created. I can do a describe, and I can say, should describe the cluster for MAAS1. And you can see that now it's actually provisioning both the control plane nodes. And once the control plane node is fully up and running, it'll provision the worker node. If I jump back into my actual, my MAAS console, you should see, if I switch by status, there should be a machine that is currently in a deploying state, right? One of them is, so one of the machines we had deployed manually using the Ubuntu operating system that I selected, but the other machine that is being deployed, you can see right now it's loading the operating system, it's rebooting it, it's doing the whole operation end to end. And so what's cool is with this MAAS, now you are able to still fully manage your bare metal Kubernetes clusters with Cluster API the exact same way that you do for Amazon or any other environment that you have. Any questions, Alex?
There is one pending. Shahar asked, how many clusters can CAPI control, and what sort of bottlenecks do you see with running a lot of clusters managed by a CAPI instance?
That is a great question. So Cluster API, by default, it's not only about provisioning, but like we talked about with the machine health check, it's also making sure each of those clusters fully up and running, or each of the machines running. Now, as you start having, I think it was 200, 250 machines, you need to start having bigger and bigger and bigger management cluster so that it can actually operate, it can actually do the reconcile across all those machines effectively. There are options where if you don't want CAPI to maintain such a large management control plane, what you can do is pivot CAPI into each and every cluster. So the way this would work is you would say provision the cluster end to end, like maybe a Amazon cluster or maybe a MAAS cluster, and then you would do a cluster cuddle move command to move the cluster API resources and the controllers into the cluster itself. And now what the cluster will be doing is essentially self-manage itself, right? Whether if one of the nodes goes down or becomes unhealthy, as long as the pod for the cluster API is running, it can self-heal, it can self-correct itself. There are, of course, downsides to this, where if the entire cluster is lost, right, who is recovering that? Who's notifying you? So generally, you would have some system that sits on top of these move operations to be able to ensure the health of the clusters are still good. But I think that's the one way of scaling, is essentially moving all the cluster API resources into the clusters.
Very cool. Alden asks, what does MAAS offer for load balancers?
Great question. You guys are all the advanced and hard questions. So there is no ELB like in Amazon, right? ELB, of course, says I have a DNS name or an IP address, and I want to go ahead and load balance across multiple different systems. The equivalent in MAAS, though, is DNS load balancing. So remember how as part of the actual cluster configuration, we specified the DNS domain, and I specified maas.sc. So let's take a look into that. If I go in here, every machine that MAAS provisions, it'll automatically create a DNS entry, the name of the machine dot the domain name. So in this case, bm-az1-70.maas.sc. If I was to go in my terminal and do a ping command, right? Let's see, right? Obviously, the MAAS controller also acts as a DNS server. It'll respond back to the actual IP address of the system. Now, how does this help with load balancing in terms of the control plane nodes? Because if I launch 3 control plane nodes, what can it do? What the cluster API provider for MAAS, what it does is whenever a new cluster is provisioned, let me find the name of this actual cluster we just provisioned. What it'll do is it'll go ahead and it'll create an actual unique DNS domain name, MAAS-2- some unique identifier for that cluster. And it can add multiple A entries. It'll manage this. So what the provider will do is it'll provision 3 control plane nodes, but for this MAAS-2 endpoint, it'll register 3 copies of this DNS name. So you'll see one that's going to be for IP 118, another one's going to be 120, another one's going to be 130. And then on the client side, it does DNS load balancing. So it makes sure whichever node is healthy. If any of the control plane nodes becomes unhealthy and dies, the cluster API will remove that DNS entry from the actual provider, from the actual MAAS, so that it makes sure that it only has healthy nodes running inside of it. And by the way, kubectl itself also does a pretty good check. Like if the first node it tries accessing is not healthy, it'll automatically go to the next available A address to make sure to try getting a response from the server.
Great. That was all our pending questions.
Awesome, awesome. So just finishing up just the last few things, right? So what's next for Cluster API? So Cluster API just released its V1 Beta 1 a few months ago. Obviously, it is now used by all the major vendors in production. There are a couple new capabilities that they're also adding in production, one of them being cluster class. If you're managing 5, 10, 20 different clusters, you don't want to manage the same configuration across all of them. So cluster class is kind of like the machine deployment object, but at a cluster level, it kind of breaks it at a higher level. This other one, this portable load balancer, is very similar to the question that was asked, where if I have my own F5 load balancer, I have my own Avi load balancer on-prem or on the public cloud, can I utilize that to load balance across all the control plane nodes? So that is going to be possible with this portable, extensible load balancing capabilities. And then the last thing is, for generally, if you're launching a cluster that has 50 nodes, 100 nodes, your control plane can have the etcd running inside of it. In fact, today when Cluster API provisions, the etcd and the control plane components are all in the same VMs or nodes. But for larger systems, if you're talking 500 plus different nodes, you may want to separate your etcd system from your actual control plane component nodes, just for scalability purposes. And so they will also add support where you can provision etcd VMs or nodes that are only doing etcd, and the control plane nodes are only for your actual control manager, your API server, and your scheduler. So. And the last couple things just to kind of talk about is, obviously we talked about provisioning and upgrade as cluster management. There was a question previously about what else for monitoring do you do? There are many, many, many different responsibilities that cluster operators have to deal with. And specifically because the requirements that comes from both from the businesses as well as from the applications are constantly changing. And so whether you need to do upgrades on the Kubernetes levels, whether it's any of the integrations that sit on top of it, or whether it's even the applications that are running at the very top, all of these things have to be managed cohesively, both from a day 0, day 1, and day 2 perspective. And what our platform, so the company that I work for, Spectro Cloud Palette, essentially deals with all these different aspects, end to end. And how I think we differentiate ourselves and how we kind of see ourselves is we provide that full stack management, whether it's talking about the Kubernetes core layers or any of the different integrations that sit on top of it. On average, what we find is customers have 15 to 20 different integrations when it comes to Kubernetes clusters. So our goal is to help make it easy for customers to be able to provision and manage those integrations, being able to do it across both day 0, day 1, and day 2 life cycles, and having complete capabilities like backup restore that is natively integrated, having operations like security, penetration, and even conformance scans that you can run in these clusters, and of course being able to support any cluster in any environment. So this platform that we offer is called Spectro Cloud Palette. But with that, any questions for a wrap up, Alex?
I don't see any pending right now. I think we've wiped them all out.
Awesome.
Oh, Scott asks, any supply chain helpers? And again, I'm pretty sure he's trolling me.
I mean, there are obviously a number of different options for everything from controlling from the development into the building aspects to the release of the artifacts into it. We don't have any native integrations today, but you can obviously add something like, forget the name of the one tool where it integrates into every single lifecycle chain itself. But it's relatively easy to add any integration, whether directly using Argo CD and any kind of GitOps approach, or whether using a platform like Spectro Cloud Palette.
Very cool.
So just real quickly, guys, if you guys have interested in Cluster API, if you're interested in taking a look at it, I would recommend you go to the Cluster API Kubernetes book that I showed you. It's awesome documentations for getting started. They talk about the concept. They talk about how to do end-to-end quick start on any of the providers that I showed you. If you're interested in MAAS, there is the MAAS provider. Now it's also integrated natively into Cluster Cuddle. So you can do a Cluster Cuddle, initialize my MAAS, initialize my Amazon, or any provider that it provides out of the box. And if you have any other questions about Palette or day 2 operations on top, feel free to reach out to me. I'm available for any questions you may have on Cluster API or Kubernetes in general on Twitter at Saad Malik. And if you have any specific questions on Kubernetes, you can also ask at this email handle, ask@kubewizard@spectrocloud.com.
Awesome. Big thanks to you, Saad. That was awesome, man. Very great content there. Appreciate you handling all of the questions coming at you like a pro. That was top notch, man.
Yeah, great questions. And thank you, team. Thank you so much.
Yeah, we really appreciate it. Hopefully we'll be able to get you to travel down to Atlanta when we move back to in person and do this again.
That'd be great. Awesome. Thank you.
All right, folks, moving on to our second presentation for the night. Our good friend of the meetup, Mr. Scott Nichols, one of the co-founders of Chainguard, is going to be helping us learn Go, but maybe not the one you expect.
Yeah, we talked about this in December, and it came up that there was a little bit of interest in this group to learn how to play the game Go, and I offered to come do a little presentation. So here I am back a couple months later, and so we're gonna take off our Kubernetes hat and put on our after hours fun hat and see where we go. So let me share a desktop here. I made you slides. That's right, I made you slides. Let me pop the chat open. There we go, so I can see that. Okay, so I'm just going to start this with the caveat of I am, and this will make sense later, I'm about a 10Q or so Go player, which makes me something like a serious amateur. I mean, like I learned and I've been playing this game for about 15 years. And I'm about average in the population of Go players. So I'm not the best. I'm not a worst. I'm not a beginner. I'm not very good, but I love the game, and it is great fun. So I'm going to teach you that, and then you're going to go off and become addicted too. So that's the goal. And there we go. So I like to introduce Go in the context of other games. So there's a phrase or a saying that says there are 3 ancient games. There's backgammon. It's the dice with the chips you move around a board, and that is man against fate or person. There's chess, which is man versus man, right? You've got an opponent, you're destroying stuff, you're trying to like destroy an army. And there's Go, which is man against self, because the thing that's interesting about Go is it's up to you to recognize patterns and then adjust accordingly to what you see. And it doesn't necessarily depend so much on the person you're playing, because any given move is really about you and your strategy and your goals and what you can read and see in the future, which makes it super interesting. It's called Go in English, but it has other names just in case you run into them. For this presentation, Yeah, sorry. Go is a strategy game. It's really about surrounding empty spaces on a board. Okay, and really that's the whole game, is surround empty spaces. And there's some nuance there. It's a very, very old game, just like the other games I mentioned, almost 3,000 years old at this point. And it really made its way into America, like the United States, about 100 years ago, or a little more, maybe 150 if you, depending on how you count, but it really started gaining steam. And there is an organization in the United States called the American Go Association where you can register. I think their website says 2,000 members are registered, but I think that data is a bit old. I would assume that there's a bit more. The popularity of Go, as you can imagine, has kind of waxed and waned over the years. It has had a long history. And we saw a resurgence of people playing and learning how to play Go because of a very popular manga that got released in Japan called Hikaru no Go. It's a very fun story about this kid that unleashes this like master Go ghost spirit, and then the ghost wants to play through him. And so if you're interested in like all of the cultural aspects of Go, what it means to play Go in Japan and like be a professional, it's an excellent book series, and it's also turned into a manga, but I don't think it goes all the way to the end of the or it's an anime, but it doesn't cover all the books. I think they trimmed the end there. And then more likely, this crowd has heard of Go from the AlphaGo program. It was about 7 years ago. Google made some waves producing this thing called AlphaGo, which is this AI program that was the first thing to actually beat a human playing Go, which is kind of this, there was a big shift in how we think about Go, because up until that point, the absolute best programs that would play Go were nowhere close to what a good human, not me, of course, but like an actual good professional player had no chance against the computer programs, because there's complexity. There's so many combinations of things to try in the board. There was no way to actually make a big enough server program thingy to brute force it. So turns out we can train models, and they just destroy humans. And so AlphaGo, and then Alpha Zero or Go Zero or something like that came out after that, was just dominated. And the fallout from that is really interesting, where when computers beat chess, it kind of broke chess a little bit, because people are like, well, what's the point? But AlphaGo kind of gave us a new tool to relearn how to play Go. So there's over time, openings of Go and what moves are worth and things like that have changed their weight over time, and AlphaGo is changing that today. There's some interesting moves that it made that humans are like, why is that? Why does that work? And so, it's this whole other new resurgence and a research tool for humans, which is pretty cool. Okay, all right, how to play. So most of what I know is Japanese influence, and there's some nuances in the rules, and I'm not going to get into that right now. But so just be aware that if you know how to play, and I'm not saying the rules exactly right, there's some minor differences between like Chinese and Korean and Japanese, and I'm going to teach us Japanese right now. So these are the rules. There's 9 rules. It's a very simple game. The board starts empty unless there's a handicap, and we'll talk about that later. The play is black goes first, and then white, and then black, and then white. Stones are placed on intersections, empty intersections. A group is considered connected if we'll go over this in a little more detail, but there's the rules. Okay, let's look at board shape. The other rule that's there can never be a board state that is exactly the same repeated. So the board has to be unique every single game sequence for a particular game. The game is done when both players agree it's done. And that's a little nuanced, but basically it means, if there's no more useful moves to play and we both agree, then the game is done and we start scoring, or one person gives up. And the goal of the game is who has the most area, the empty area, and we'll kind of look at that. Okay, so there are three common board sizes that we play on. There's the 9x9, which is really like a learning board because the games are short. There's the 13x13, which is an intermediate board. It's kind of like a classic lunchtime game. If you want to play a quick game, it's like 20 minutes. You play on a 13x13, but it's still just it's a learning board. You would, and then the real game is the 19x19. Note that all these boards are prime, which is kind of interesting, except for the 9x9. That's not prime. Well, 19x19 is, anyway, okay, so that's the board size. The parts of the board, so I said intersections, and I literally mean the intersections of the lines on the board. So valid intersections are up in the corner, on the side of the board, and in the middle of the board. The little dots that you see are these star points. And star points, they tend to be where the handicap stones go if you're playing a handicap game. What handicap is for is if I'm a player that has a rank and you're a player that has a rank, we can kind of check our ranks out together. And the difference is how many stones you play or I play against the other person ahead of time to make the game equal. And it works out up until, it gets a little funny when you're more than 9 ranks apart because maybe you don't have a chance. And then there's other ways to make it more fair, like points and stuff, but that's not that important. Okay, so the real meat of Go. So Go is consisting, every time you place a stone on the board, it's considered a group. A group has liberties. A liberty is any directly adjacent empty intersection. So if you play, can you see my mouse? Yeah. Okay. So if you play that stone up in the corner, it has, when the group is played, it has a liberty of 2, which is not very good, right? Because you really want more liberties so that you have, I should tell you why. Okay, so this stone down here in the corner, all of its liberties were removed because maybe this white stone got placed. It is dead and removed from the board. Okay, so it's really easy to capture a stone in the corner. It's harder, but not impossible to catch one on the edge. And if a stone is placed in the middle, it has 4 liberties and it has much more room to play, right? If a stone is placed adjacent to another stone, it becomes the same group. If the 2 stones are directly touching, not diagonally, like in this example, this is 2 independent groups that just happen to be close to each other. They share a liberty, but they're 2 groups. These 2 stones are 1 group with 6 liberties, okay? So you get into these really interesting situations where you can kind of assert influence by the diagonal connections, but like this stone here is at risk of getting captured because it only has 2 liberties and white could play in a way that captures it. Okay, so and then there's other situations where white could play a move like this and black is surrounded, only has 1 liberty. And then if black extends, they get more liberties, but then white has a chance to take those liberties away, right? And if all the liberties of a group, a single group, are removed, the stones that lost their liberties are taken from the board, with the one special case where if playing your stone inside a shape of another player, so I'm black, I play it into white, I take white's final liberty of that group. If I can take stones out of the board and my stone survives, that's a valid play. But I can't just throw a dead stone. Like if this black stone didn't exist, I couldn't just play a black stone into there because it's not, there's no valid move after the sequence is done. Okay, so that's liberties, and that's kind of the basic mechanic of how to play Go. Except
quick question. If you go back, what is the difference between the stones that had the squares, the black stones that have squares versus circles?
Oh yeah, I'm just trying to show you that there's two different groups there.
Oh, got it.
You know, they don't really have this. It's just like a drawing, right? But you know, these two stones are next to each other, but they're not the same group. There's two groups there.
Got it.
And this kind of illustrates why they're disconnected by the white. So there's two groups here. Okay, so Go is all about making shapes, and the ultimate goal is you want to make empty space. And if you have empty space, it means that you have eyes, and that means you have life, right? So so in this corner, there's no way for white to play into my shape if I'm black, because if white were to play here, their stone would have no liberties, and it would be removed from the board, and so the board wouldn't change states, and so that's not a valid play, right? And same with this, right? It's very thick, but it's alive. And again, like this black group here it's alive because it has two eyes, and it's composed of two individual groups. Now, if black were to misplay and connect one of these eyes, it would have one liberty inside, and white could play into that spot and take all the stones, right? So here's the fun part about Go. So you see this middle group in here. Pretend the white stone isn't there and it's white's turn. White has an opportunity to play inside this shape and take the eye from this cyclops, right? So because white played here, black no longer has an opportunity to split the space into two distinct eye areas. And so white could follow up and play here, black could take them, those two white stones would be removed from the board, and then white could play again, and then black could take that white stone, and then white could take the whole shape. And this is something that happens quite often. So when you're developing shapes, what you're kind of thinking about is leaving enough room for at least two eye shapes in your structure. And this was done, so pretend these two stones weren't here. If I were black and I had this shape, and white tried to steal my eye shape, I have to play here to divide the space so that white can't play there and make that big open space into just one eye, because then the shape would be dead, and it would be white would take it from the board at either the end of the game when it's scored, or through a sequence of threats that you could do. Okay, so one more note about walls and groups. The edge of the wall is basically like all of the same color is connecting you from the two places that you connect. And what does that mean? So these three shapes that I've drawn here are basically equivalent, right? Like, ignore the fact that they're dead because they don't have two eyes, or if they were surrounded, they would be removed, or they could be taken. But it took 3 stones to capture 1 point in the corner. It took 5 stones to capture 1 point on the edge, and 8 stones to capture a point in the middle. Right? So there's an efficiency of trying to leverage the wall in the corner, and you have to pay a lot to capture space in the middle. Is that clear? Everybody good with that? So, and I'll come back to that in 1 second. So I talked about there's this, you can't return the board to an original state. There is something called a co-fight, which is the simplest form is this, right? So if it's white's turn, white could play here and take this black stone. In black's turn, black cannot play here again directly, because that would return the board back to the original state. This thing is called a co-fight, not the go-co, but this is co the other way. Yeah, brought back. So this is the fight part is, white plays, it's black's turn. Black has to find a threat that's bigger than the value of taking maybe filling this white spot empty spot that's left behind. So it's got to go find, anyway. There's also something called the ladder, where it's this sequence of, if it's black's turn, black could play, white could block, black could play, white could block, all the way down to a wall or another group. And the beginner job is to identify these kinds of shapes, because the every move here, unless it has a meaning that you're trying to go for, they're dead stones, because there's no way for them to survive and make life yet. So when a group has just one liberty, it is said to be in Atari, just like the video game. That's where they got the name. Atari kind of means check, but for the specific group in that local area. So when you're playing a teaching game with somebody, it's often nice for the teacher to say Atari for the student, because they might not necessarily see complicated single liberty groups. So if you hear Atari or something, that's what people are saying. There's like there's a group somewhere that has the chance of being taken in the next move. Okay, so I was saying that it's more convenient to try to capture the corners and then the sides and then the middle, because of the efficiencies that you get. So in general, this is kind of like a heat map of where people play in the beginning. So the general flow of a Go game is there's three kind of distinct sequences, and there aren't any specific rules about this, but usually in the beginning, what you're trying to do is you're trying to lay stakes for area that you would like to build on, right? Mid game is, well, I'm going to try to build those walls for real, but not all the way down to the walls, because I'm still trying to grab as much territory as I can to make it real, but I want to prevent you from invading my area too. And then the late game is getting to test the theory that you owned that land. So very general. So let's see. I grabbed an online Go game and I was kind of like looking through it. And so here is the first 30 moves of somebody's game that I found. And this would be sequenced up until the end of the opening. So they've played the opening and now they're kind of starting middle game. And oh my goodness. Hold on. Not getting away that easy. I pushed the wrong button. There we go. Okay. And then, so here they've, white's asked, I think I own this corner, and white also owns this corner. White owns this corner. Black owns this section. They kind of split this corner. Unclear who owns this area. The middle's maybe black, and then it continues where they're defining those borders and edges. What they're trying to do is capture empty space without getting invaded and trying to invade. It's kind of this like funny, delicate balance of like, how far can I stretch without be stretched too thin, so then I can be overrun. And then this game concludes with the borders all defined, and then the score says that black wins by 2. So it was a very close game. And notice like there's some dead stones that got taken. When a stone is taken from the board, it's basically a negative point in Japanese scoring. So if I'm playing white and I took the black stones, they go into my side and they count as negative points to you towards the end of the game to score. Okay, so I talked about those board sizes, right? Well, the reason why the small boards are kind of like for funsies is they don't have all the sections of the game. So only the full board has the middle of it. The 9x9s are really convenient because they're quick games to play, but they don't have any sides because they're too close together. So you don't get to practice the side play and it kind of expansion. And once you get the hang of playing for corners and playing for sides, then you can add in the middle complication and then you play the whole thing together. Okay. I'm hoping general sense of like, I understand this might be a possible game that you play. I know I didn't really talk about like sequence. There's one other little thing. If you're going to try to go out and understand how to play games online, is you have to understand what the ranking systems are. And it's similar to chess, but not exactly the same. Go is scored through, again, this is the Japanese way that I know how to talk about it. There's something called a Q, which is the rough translation to like a soldier or somebody, like a footman. Your score today, congratulations, you are a 30 Q if you just learned the rules. All right, nice work. And then as you learn how to play, you become something called a Don, which is like a general. So there are actually two kinds of Dons. There is the amateur, which is like what you could possibly get to as a normal person. And then there's the professional Don, but you have to take a test, and I'm too old for that. So I'm only ever going to be an amateur. So that's too bad for me. But the most interesting thing about this is the individual Q and Don section. You could kind of think of it from like -30 to 10. Each click is a standard deviation from the center point of the population, and it matters the population. So if me, a US person, wants to play someone from Japan, we have to also be aware of the standard distributions of our ranking systems to be able to play fair games together, which is kind of fun. So if your country is strong, that deviation, like standard deviation, might trend higher. So if you came to the United States as a really strong Japanese player, your rank might be several ranks above where you started at in Japan, just because the population isn't as strong as where you came from. So I think that's super interesting, but maybe not relevant yet. But you'll get there. Okay. So there's another saying that says, if you're interested to learn how to play Go, you hurry up and lose your first 500 games. It is a steep learning curve, or shallow. It's a long learning curve. There's a lot of stuff to learn, and it's very fun, but there's a lot of stuff. There's a lot of nuances that are going on. A good way to learn is also to play life and death problems. So if you're given a shape and you're asked, like, it's black to play, how would black allow this group to live with no question, is the problem style. And then the other works the other way, like, given a shape and you're the other player, how could you kill this unconditionally, or something like that. And then eventually, once you've played your 500 games and you've learned a bunch of life and death problems, there is something called a joseki. And a joseki is a known localized pattern of play that, or a sequence of play that ends with equal result. Right. So this actually has made its way into normal Japanese culture, where, like the business joseki of whatever deal making process is yada yada. Right. And what they mean is, like, there's the sequence of how we work out the deal so that you're happy and I'm happy, the win-win. Right. So joseki is really about knowing the sequences for win-wins, but you also know it so that if they misplay, you can make it a win-lose. And that's the point, right? Trying to win. There is a ton of awesome, much better content than I can do from a whole host of people on YouTube. So click these links. I'll send out the slides later through Alex and whatnot. And then time to play if you wanted to play. So I was thinking, for the folks that made it this far, we would try to do some sort of simu play thing if you want to play me all at the same time. I don't know what people think about that, but I'm game if you're game. And I'm going to pass it to Alex to wrap the night up.
Awesome. I am super excited to lose my first 500 games. Hopefully my first couple to Scott here in a minute. Unfortunately for people on YouTube, this is where we are going to leave you, but you could probably go try to find Scott on Twitter and get him to play a couple games with you. Thanks for coming out, everybody. As always, we're always looking for speakers. If you have a talk you want to give, reach out to us via meetup.com or Twitter. We're pretty easy to run down. We're pretty much KatesATL everywhere, or katesatl@gmail.com. We'd love to have you come out and speak if you have something interesting to talk about. Or if you just have a topic you want to learn more about, feel free to reach out and let us know about it. And we'll try to hunt somebody down to teach us about it. All right, thanks for coming, everybody.